All right, so Quinn is flying a kite. The angle of elevation formed by the kite string and the ground is 44 degrees. The kite string forms a right segment forms a straight segment that is 90 degrees long. So here's our picture. The angle of elevation is 44 degrees, like that. And the kite itself is 90 feet long. That's the thing about this. If you've never flown a kite, and I don't know that I've flown one or haven't a really long time, is you have to remember that it's the string length is the hypotenuse. All right, so it says explain how to find the distance between the ground and the kite. That's X here.
Mhm.
Include a description of the triangle you drew to help solve the problem, including the variables, measurements you assign to each side and angle. Round your answer to the nearest foot. Okay, so I think you have to, excuse me, you have to figure out how to label this triangle. We have to explain how to label a triangle. So best way to do it is to do exactly what they've been doing the whole time. It's to say, given right triangle ABC with 90-degree angle B.
Okay, cup. I got it.
So what this does is it tells you that the triangle is this one here, and it's got a 90-degree at B. What you don't know is where A and C are. So that's where you've got to add a little bit more information. You have to say vertex A is the position where Quinn is flying the kite from the ground, and C is the location of the kite Is that okay?
Yeah.
Great. So now we've said enough to describe this. So now you can say the length of segment AC is 90 feet. This is the hypotenuse of the triangle.
Got it.
All right, next here, the measure of angle CAB is 44 degrees, and this is the angle of elevation formed by the ground and the string.
Yeah. All right. Yeah.
Got it? Got it down?
Yeah.
Okay. So now the next thing is, well, how are we going to explain that we just talked, or I'm sorry, just how are we going to explain how to find X? Well, you have to, so I want you to give this a try. So basically this is the part where we're just doing what we've always done, which is sine, cosine, tangent. So I'd like you to write a few words and drop them in the chat for this part to find X, please, whenever you're ready.
Find X. So,
Yeah, we have to find X.
um,
So your hint is you're going to use, sine, cosine, or tangent. You're going to kind of set it up.
yeah.
And
See, you would use cosine. Let me put this in the chat. Cosine 44. And or cosine of 44 equals X over 90 because X is the
right.
adjacent. side. And 90 is the hypotenuse. So let's put
Okay, so you put some things in the chat here. Let's take a look here. Okay, so I'm looking for some more words, Karthik. I'm trying to get you to
so
write a
maybe
few
you
words.
say like here, let's see. Using one second, let me put this later. 90. The nearest place. So I put it in the chat now.
Got it. So let me grab it here. So one of the things we did not do is actually identify the, so we might want to say that here. We might want to say that x is the distance from
Oh yeah, we need to
in feet from the ground to the kite. All right, so using the cosine of angle A, so you might want to say y cosine.
Oh yeah,
Oh, you do say that the adjacent side over the 90, the hypotenuse. Good. That's good. By multiplying 9 both sides, you get 9. So solving x price 650. Yeah, that's good. That's really good.
yeah. I kind of just explained the steps of like how to come about like x is approximately 65 feet long,
Yeah.
which like round to the nearest twist. So all right. Mm, all right. Okay. Um, yeah, this is the last written question. All right, so there it is on the chat.
Another written one, or is it?
Yeah, it's in the written one.
All right. How many of these are there?
This is the last one.
Last one. Okay. An observer O is located 500 feet from a school S. The observer notices a bird flying at a 39-degree angle of elevation from his line of sight. How high is the bird flying over the school? You must show all work and calculations to receive full credit. Okay. This actually is much more straightforward than the last one here. I mean, this is 39, this is 500, and this is H. So, I mean, do you have to give an explanation for which trig function you're going to use? Or do you
I
just have to solve it? Because like it just says to solve it.
think it's just solving it for this
Okay,
one.
so this is really similar to what you just did here. So I guess just go ahead and try writing something out and I'll take a look at it.
Let me write it down. Uh, so this is H. All right. All right, so you would use opposite for adjacent to tan. So tan of 37, 8, step 2. Maybe put this with the next. So for this one, we just round it to the nearest whole number.
Yes.
All right. Be 3, 7, type up the See. So for do you have to state that you're using H for like the variable, or is that kind of like a given here?
Doesn't say that, so you might wanna, no, it is given. Yeah, I'm sorry, it is given, so no, you don't have to, you don't have to do that.
All right. So we're using using- Oh wait, isn't it 39 degrees?
Sorry, yeah, I mistyped that, or it is 39, yes. It looked like 7. I'll make a cleanup here.
This thing.
How are you doing on this one?
Uh, almost done. Oh, 2 years. All right, this is what I wrote for it.
Okay, yeah, let me take a look here. All right, so you gotta be careful, really careful here when you use one letter for an angle. So it's better to say angle SOB or BOS. Maybe BOS is better.
So it's better to use like the whole 3 letters to describe an angle rather than just like the one letter.
Well, it's it's this one is probably okay, but and the reason is because there's only one angle there. B could be referring to this one up here or this one inside here. Always better to use 3 letters whenever possible. The
Gosh,
adjacent side is 500. So you might even say the adjacent segment, maybe segment or I'm sorry, side, segment OS is this, and opposite side, segment BS is H using tangent. The tangent 39 equals H the opposite over the adjacent 500. This would give you tangent 39. Yep. Multiply by 500, which would give you 539 equals H. Multiply H by 405 feet, round to the nearest foot. That's perfect. Okay. Yeah, I like it.
all right, yeah, I just
Very
kind
good.
of use the same language that I did in the last one.
That's perfect. That's all you
What
need to do.
I'm looking for. All right, so let me put this edited one into the thing. Let me just what's there. What's that thing? All right. All right, let me see. All right. Then, all right, next step, I believe we have to go over the first lesson in module 6. Just going over like the basic formulas for
Sure. Yep.
module. So let me pop number 1 into the chat.
Are we still pretty much on track in this class?
Yeah.
That's good to hear.
All right, let me put this in there. All right, it's in the chat now.
All right, let's take a look here. Circle has been dissected into 16 congruent sectors. The base of one sector is 1.17 units and its height is 2.94 units. Using the area of a triangle formula is the approximate area of the circle. So here's what they're saying. The base of the sector is, what are they saying here? So I guess this is I'm guessing here because I've actually said that they don't usually refer to this as the base. I guess this is 1.17
Yeah,
and the
I think
height,
that's referred to it as in the lesson as well for this
and this
activity.
is 2.94. So it's approximately a triangle, I guess.
Yeah, because I took what I did for this one is I took the 2.94 as the radius, because that's technically what it would be, right?
Well, it says, so that's different. Um, I think it says the height. The height is not necessarily the radius. It's the distance from the top, the center all the way straight down. Okay. So let's just play this out here. So it's 1/2 base times height. 1/2 the base, which is 1.17 times the height, 2.94. That's the area of one of these. And then the area of the circle is going to be 16 times this. Okay, so I'm gonna just do this calculation here. Maybe we get lucky here and it's one of the answers. Yeah, so 27, I get 27.52 like that, which is the second one here. Did you actually get 27.14 or was that just clicking on it?
I got 27.14 by using 2.94 as the radius, and then doing the area of a circle using that.
Okay, so I can't speak to that because it does say to use the area of a triangle formula. So if you're not using this, feels like you can't really get it correct.
Got it. So you're supposed to find like the. Oh yeah, that makes sense. Yeah. Got it. All right. So the next one's in the chat now.
Take a look here. All right, so the cross section of a rectangular prism measures 1.5 units by 1 unit. The cross section of a triangular prism B has base that measures 2 units, height of 1.5 units. If the length of each prism is 1.81 units, which statement is true? Okay. So I guess we need to first label these. So the rectangular one is 1.5 by 1, and then the triangular one has a base that measures 2 units and a height of 1.5. So the area of A is 1 times 1.5, which is 1.5. The area of B is 2 times 1.5 divided by 2, which is 1.5. So these have the same cross-sectional areas. Do you agree with that now that you've seen it worked out?
Yeah.
Okay, so the volume is the base, which is the cross-sectional area times the height. Base times the cross-sectional area times the height. Now, we know the height. The height in this case is the length. The height represents the like distance extended. In both cases, it's 1.81.
Oh, so it is the exact same.
Yeah, and the bases in both is 1.5 and 1.5, so the volumes must be the
So
same.
it's not going to be like volume B equals 2 times the volume of A.
No, because the cross-sectional areas are the same.
Got it.
Like it's easy to look at it and be like, oh, B must be half of A, but you're making an assumption. You have to go with the numbers that are here.
Got it. Hmm. All right, this next one's gonna be in the chat. I didn't do this one yet because I was kind of still not sure how to do it.
Let me see if I can hint here. All right, so here's a cone. Cone is the party hat. Do you have a volume reference sheet?
Yeah, I think I do.
All right, so I'll send you one that I really like in the chat here. It's got everything. Wow. Yeah, it took a while for me to find one that's got everything. Now the volume formula for a cone is 1/3 pi r squared h.
Got it. Yeah, I just opened up the reference sheet. Oh yeah, this has the area formulas for all of them.
So here we go. It says a cone has a volume of that and diameter of that. Which state, Wilson states the cylinder with the same height and diameter has the same volume. Which statement explains whether or not Wilson is correct? So basically, I think you've got to use the height and diameter. Notice this does not have diameter in it. It has radius, so your radius is really 6 in each of these. I guess see which one of those might work. Like start with the ones that are correct. Let's see if either of those actually work. And now when you're using this formula with pi, you can also wait until the end to put the pi in. So it's 1/3 r squared h, and then there's this pi off to the side.
So if r equals 6, and then the um e is 6 that's 30. And it's the first one.
Okay.
Alright. Yeah, it's this one. Number 4 is another one that I want. It's in the chat now.
Right. Is this today's assignment or what's is it
Um,
tomorrow's?
so for tomorrow we finished. So what I did over the weekend is I kind of worked on I completed like on the activity that we did in the first session today. The first activity we did, that number 8 problem, that was part of Monday's work. So we finished off Monday's work. And Tuesday's work we've also finished off because we finished the part 2 test and the part 1. That all
Okay.
was part of
Wow.
Tuesday. So this is as of right now. This is when I believe actually no, this might be
Doing great. So rectangular pyramid, here's a rectangular pyramid. It's got a rectangular base and then it comes down like that. Okay, now the volume of the
yes.
volume of a rectangular pyramid is 1/3 base times height. Base referring to this B refers to the area of the base.
Got it.
Now, Shannon states that a rectangular prism with the same base area and height has a volume that is 3 times the size of the given rectangular pyramid. Which statement explains whether Shannon is correct? Okay, so I'm not trying to tell you to do this, but in a rectangular prism, if this is the base area, here's the height, there are these posts. Okay. The volume of the prism is base times height.
Got it.
So we're looking for something where the base times height is 3 times the 40.
Base times height. So is there- yeah. Not sure if this is correct, but I think it's number 3.
I would agree.
Yeah, because I did here's that, and that the first one I was trying the first one, then it did not come out to like 40, to 120, so the third one would be correct. That's what I think would be correct.
Okay, good.
All right, so this last one, number 5, I did it. I wanted to kind of check if it correctly. So yeah, I'll put it in the chat. All right, it's in the chat now.
Right, the stack on the left is made up of 15 pennies, and the stack of the right is also made up of 15 pennies. If the volume of the stack of pennies on the left is 375 millimeters cubed, what is the volume of the stack of pennies on the right in cubic millimeters? Only enter numerical numerals in the answer, 2 points. So the way this stack on the right is sort of manipulated is it's like, does the composition,
Yeah,
like if
because
it, what?
yeah. So we learned in this lesson, particularly we learned about Cavalari's principle, where if it's like a perfect stack up straight, like it would be the same height and diameter and everything as if even if it was like skewed a little bit and it was like, not, it was just arranged and it was like, all drag on the top, like it would still be the same height and uh diameter, and if it were to be so.
Yeah, so the simpler example is when you cut up fruit or something like that. Like I don't know, we could say a banana or an apple, right? When you cut it up, it has the same volume as when you started. It doesn't matter if it's cut up. Does that make sense, or do you want me to give you a better example than that?
Yeah, that makes sense.
Another analogy is that you've got water in a cup, you pour the water in another cup, it's the same volume.
Got it.
What I was trying to show you here is that like the sum of these shapes, some of these volumes, is the same. Like
got
you don't add or you don't lose or gain material when you
got it.
cut something up. So hope that helps.
Got it. So in this case, if we were to take the stack on the left that says made of 15 pennies and is also in the stack on the right is also 15 pennies, and the left has 375 millimeters cubed, so then the one on the right would also be 375 millimeters cubed, since you're not losing any volume by disarranging it. So it would be 375, right? Alright, so let me. I think I already have that. Yeah, right. Let me go ahead and. Alright, so I ended up submitting it, but I think that. So I had to go over this question. Yeah, I put it in the chat. I think it was number 3. Okay. Yeah, so it says the correct answer was I think it was a cylinder in which H equals 12
Oh,
and
it's okay. Yeah, it's like the other one. So I'm sorry. So you're looking for the one that states the cylinder has the same volume. And that's not true. It's gonna have 3 times the volume.
oh
Yeah, I
god.
wasn't really paying
Yeah,
because what it is the cylinder fits or the cone fits inside the cylinder perfectly.
got it. Yeah, that makes a little more sense. Got it. All right. Now that we're done with that, I also but here. All right, so now we're in 6.2. This one's applications of volume. Let me put the first question in the chat. All right, the first question's in the chat. Yeah, it's the one, but yeah, but
This one here, number 1.
yep.
All right, a square pyramid. So again, you kind of want to draw something. My pyramids are just, I don't draw them very well, but this is, you draw a square base, you go straight up, and then you connect all those. So that's your square pyramid. So there's a height of 9 and a volume of this. So the volume of a pyramid is 1/3 the area of the base times the height. So they're giving you the volume. The base is unknown and the height is 9. Okay, now if a square prism, here's the square prism. So there's the square prism. It's got the same base area. Okay. So we need the base from here. So have you solved this for the base in this equation?
For the base,
Yeah.
so here, let's see. Yes, you could do. Right, let me get that one higher. 9. And it's 147. I got 49.
Okay. Yeah. So B is 49. So now the prism, the square prism, again, it's got these heights here. Okay. So we know that the volume of a prism is the area of the base times the height. So it's saying it's got to have the same volume, 147. The base is 49. So what must the height be?
The height, well, if it down to 49, it would have to be. It would have to be 3.
Yes.
Oh,
Very good.
got it.
All right, probably a good place as far as any for us to stop here today. So hope